get started. Yeah, a second order differential equation we can definitely talk about. So yeah, hi Thunder, hi Anders, and hi Joseph. So yeah, if read us on the question, Thunder. Why, dude, can't play the current? Why are you being stupid, music player? It's been stupid all day, which is just like me. Now you're working? Okay, all I had to do was close out of it. Wait, are you? I can't tell. Okay, it's just starting quiet, yeah. Is it gonna get louder at any point? Oh, it's because my volume is low, duh. Oh my god. Okay. Probably could say be a little louder on the stream though. Okay. It's probably about right. My understanding of second order differential equation is very bad. I'm so lost with the case when you have double roots. That's just, personally, it's something that I just memorize. It's you have e to the 2, like in this one you have e to the 2t, and then you have another e to the 2t, we just slam a t in front of one of them. But why? Oh god. When it comes to differential equations, y is not my forte. Yeah. Or oh my god, I literally just saw Obi talking about stuff like this yesterday. I wish I actually paid attention. Why can't it be x squared? Let's figure it out together, I guess, because I don't know the answer to this offhand. Syntax error. Starting some physics stuff. RN's right now studying some basic quantum stuff, but it's still kind of where I can see an experimental exercise in the book. Do I get to build a particle accelerator? Yeah, but good luck finding the materials. Give me class Jeff. IDK, but also I was sure rolling out. Currently I have linear algebra analysis 1 as well as mechanics. Like what's on the menu? What are your options? Actually, I don't think I ever even asked you, what's your major? Drop the A. Huh. So the question you're having a stroke on. Okay. Next course you have 3 math courses simultaneously. I'm doing physics ahead of time, so you'll be stretched too thin. Oh, nice. Are you doing quantum physics? We'll be submitting changing concentration next year to go to MSc. Ooh. Wait, is that master's in software engineering? Or mechanical something engineering, maybe? Basic stuff. Oh, okay. Material science and engineering. Okay. That's cool. I mean, you haven't already done the differential equations. That's kind of like one of my favorites. Oh, what the hell is this? Explain why lambda x e to the x is a form for the particular integral for the differential equation. It's not? Okay, so we're talking about the particular solution in particular, I guess. Which is not necessarily this. Oh. Huh. Okay, I see the I think I see the point already, but I guess like send it so I can verify it, Thunder. But okay, so I guess I see what's happening with what the point of this question is. So I see now why you're asking why do we get this stuff. It gets worse? Okay. The most random shit out of anywhere? Oh, good. Okay, so I think I can explain why your other solution has that. How did you say ax plus b? Or a plus bx? The answer to that question is a little bit long, though. I'll tell it to you, but I don't know if you want like a. There's a bit of algebra that you have to do to actually get to that. So I guess you let me know if you want to like venture down that road, but I will do it. I just want to not use a bunch of time on something that's not that important to you. Question is like, how do I know when to stop? I can just do x to the n. That's fair. You only ever want to do like the minimum degree that you have to. Yeah, this is like a weird like case for a differential equation. The only options I really have right now are the chem series, bio series, humanity, social science, language series. I can also register mathematical statistics or discrete math for CS. I mean, personally, when I was a college student, I was trying to get like the humanities and art classes out of the way. So if you have to do like a humanities or a language, I'll probably just do that to get it over with personally. So what do we have here? Plus y equals e to the x. Okay. And so I'm going to assume that you know about like the characteristic polynomial and how this informs the homogeneous solution to this differential equation. I'm going to repeat a root of positive 1. So our homogeneous solution is going to be c1 e to the t plus c2 t e to the t. And the homogeneous, it just kind of is what it is. Like for the first part of it, we said e to the t because that's kind of like just from a normal differential equation. But this has multiplicity too, and we need to make the second one different in some way. And so I just kind of like the way you do that is just putting a t in front. I imagine if you had some like third degree or third order differential equation, and you somehow got like r-1 cubed equals 0, then you might get a t squared out of that. Don't quote me on that because I don't know, but that's my assumption. It's basically a power of t for each like multiplicity you have, I guess is what I think is happening. Why can't you also have c3t squared? You can put it off later, so you can pretty much have chill coursework. Oh, that's fair, I guess. Depends on your situation. So your question is, why can't you just make that t squared? I imagine it just won't work. If we were to check, oh, well, actually, see, the weird thing is that t squared, it does work, and we're getting it from the particular part, but not the homogeneous part. Which is weird, or like it's what we're supposed to get, but it's like hard to explain. It does work, yeah, because we get it from like part B. So okay, wait, but this is the homogeneous solution. So if we took the homogeneous version of the differential equation, will it work there? That's the important question, now that I think about it. I assume it won't work in the homogeneous if we let y equals t squared e to the t, because, we're taking c1 equals 0 and c2 equals 1, so it should be valid. Y prime is 2t e to the t plus t squared e to the t. Y double prime equals 2 e to the t plus 2t e to the t plus 2t e to the t plus t squared e to the t. So if we plug all these in, we should not get a true statement, is what I'm expecting. Y prime. Or maybe we'll get a true statement, but only for like t equals 0 or something that doesn't matter. Because this is from the homogeneous solution thunder. Obi, yes. I think I saw you just working on stuff like this on yesterday. But Thunder's question is basically, why in the homogeneous solution to this differential equation could we not, so with like a repeated root, why do we only go to 1 power of t and not like t squared or t cubed or something bigger? That's what I work with that. I need to work that out still, Thunder. I'm not sure. It might, which would be disturbing. Should get c equals 0 for higher powers. Really? The music is ridiculous. Yeah. It's there's a genre of music called electro swing that I unironically like, and I put it onto the radio for a song that I like, and it's just whatever Spotify thinks is related to it, which is usually not at all accurate for me at least, but so next, do I know any good resource on Fourier transforms? I don't know of any offhand. Merriweather Remark might. Yeah, offhand, I don't know of one. Are we actually getting 0 out of this? The t squared, each of the t's do go away. So wait. Plus 1 t squared e to the t minus 2 t squared e to the t plus t squared e to the t becomes 0. 4 e to the t minus, oh no. Oh wait, 2e to the t. This thing does not get canceled. Okay. That's what saves this. So, and that's why it does work for the particular. Sorry, I made all this t's. I'm so used to doing differential equations with t that I accidentally switched to t. They should all be x's. Sorry, that's what you were saying before and I didn't get it. And so, yes, before what we're doing with homogeneous, because this characteristic polynomial stuff gets the homogeneous solution to the differential equation. It solves the case when the right side is 0. And the particular solution is almost like an offset to make it work for this exact case when it's equal to e to the x. At least that's how I remember Obi describing it. But wait, what if you, okay. You get it all now? Okay. Like the entire question? Okay. T equals x and, oh, that's what you, true, Jed. Feels like there's like a complex variables joke in there. Okay, solve differential equation that subject to these boundary. Okay. See, now they're not doing the dy by dx of x. Ugh, okay. Okay, so do you just want to see this one from the ground up, or do you have a question on a specific part? See how I tackle this? Okay. I'm gonna need to look. Actually, let me just look at the one part now. There are at least 2 ways of dealing with a non-homogeneous differential equation. I'm gonna assume the one that you're working with, or you might even learn both, but is undetermined coefficients, which is guessing, but very good guessing. Like, do you guess a sine of 3x when you match it? Okay. Okay, yeah, this is like their. Oh, really? We do need the cosine also. Hey, Fembox. Why did they only guess sine in that example? Okay, fine. I'm trusting Paul. Okay. You're not gonna. It's gonna be a sine 3x plus b cosine 3x is what I'm planning to guess here. Would it? Oh, is it even worse? It shouldn't be, I don't think. There's gonna be a lot of algebra involved here, but that's kind of the nature of the beast. Um, yeah, so we can definitely get the homogeneous one. Wait, Pemux, you're saying we should put an x in front of that? Why is that? I feel like we don't need an x. Only if there's an x in front of the sign in the particular. You do need the x? What? No way. Oh wait, is it gonna be repeated? It's gonna be, or no, this is gonna be imaginary. Oh my god, you do need the x. Okay. Dude, this is evil. Yeah, I hadn't worked out the homogeneous part yet. Okay. It's because we get imaginary roots. So I would have figured this out once I saw this part. 3i, because we subtract the 9 over, take the square root of negative 9 to get plus or minus 3i. And how does this work again? That means our homogeneous is C1e to the 3it plus C2e to the 3it, and then we would use Euler's identity on this, right? I feel like we just end up with signs, I think. Wait, this doesn't feel right what I just did here. Or like, why is it? I know in my head that we should just get signs for this. I'm trying to remember the justification for why. You do get cosine as well? Huh. I thought it was purely imaginary. Oh, that's okay. And then okay. Is it showing my stream? It's because the e to the real part is 0. Okay. That makes sense. Okay. Then we can do some cleaning up. I think we just absorb the I inside the constant because it's just a thing that we're allowed to do. Cosine is an even function, so cosine of a negative thing is the same as cosine of a positive thing. Sine is an odd function, so sine of a negative thing is the same as minus sine of the positive thing. And then we can group things up. The cosines and the sines. And then a constant plus a constant is constant, a constant minus a constant is constant. So I'm just gonna do the typical differential equations things of being fast and loose with constants and recycling the names C1 and C2. Okay, so that's our homogeneous solution there. Now, were you saying that it doesn't work, Thunder, or? It works? Okay, cool. Okay, so normally when we see this on the right hand side, we would guess I switched it. I did it again. I'm sorry, differential equations are meant to be with t. I can't stop using t. I'm sorry. Make them all x's like in your head, I guess. Okay. Normally would get for the particular a sine 3x plus b cosine 3x, but cosine plus sine is taken by the homogeneous, so for the same reason as the last one, we just kind of sneakily stick an x in front of the thing that we're going to guess. Why you can't use x sine 3x only? That's something that I thought you could do for some reason. Oh wait, you're asking not the exact question that I was thinking too. Like, why not x squared sine 3x? I think it's gonna be the same issue. We could take the particular solution, x squared sine 3x, and try to plug it in, and it shouldn't work. There should be some term that doesn't cancel. But yeah, I think the reason you can't just go to like whatever higher power you want is that I think you're going to get some kind of loose term that doesn't cancel. More or less, yeah. There are some techniques that are a little more like procedural. But this way, in terms of coefficients, it really is just very educated guess and check. There's another technique called variation of parameters, which is more just like following a formula and it spits out the right answer. But sometimes undetermined coefficients is easier, sometimes variation of parameters is easier. It kind of depends on the equation at hand. Do you get the question? Okay, sounds good. Oh yeah, I mostly you said earlier, Obi. I want to try one later as an x squared e to the lx in the inhomogeneous portion to see if we need to make the inhomogeneous solution long enough to clear the null space. And then escalate the polynomial, which you need to escalate the individual term. Yeah, I don't know. You're also not showing the proof for why n squared plus 9 equals 0 gives you the homogeneous part. See, you probably have to because of the way the A levels works, but like you question this a whole lot more than I did, which is a good thing. But like, yeah, I just kind of accepted all this stuff and memorized it. Oh yeah. Okay, this explanation is actually not so hard. So do you mean in general why this like polynomial thing actually works? Oh yeah, it is. It's by Caravan Palace. Oh, I wasn't doing this, but they have some good songs. Just kind of guess it. Proof of, oh yeah, I never gone through proof of variation of parameters. Okay, so the reason why this thing like even works is let's just take a, well, let me give it in the same notation. I'll just use the same example. Well, no, I would need the example from the previous one. We just have this and we want to solve it. We're going to make a very inspired guess. We're going to guess that y equals e to the rt. And the reason why this is such a good guess is that oh my god, I did it literally in the first thing. E to the rx. And the reason why we love guessing e for differential equations is that e to the x has this very nice property that it is its own derivative. So if we let e to the x equal y here, it is the function such that dy by dx equals y. So anytime you have an equation like this, that's like more or less relating derivatives to themselves, there's a very good chance that it's going to be e because of this property here that e to the x has. And so we do put a constant in front of x because that exponent could have something in front of it, but what we're going to find is we don't need a constant in front yet because any constant in front is going to end up working. Okay, and so if we proceed with this, the only real test is to figure out what r is. We already have our guess where the solution is going to be. And as long as we figure out what r is, we can always prove that it is the solution at the very end if we were to plug it back in. So that's kind of how it works, I guess. So if y equals this, we want to plug it into here. Dy by dx is r e to the rx, d squared y dx squared. We get another power of r coming down, is r squared e to the rx. Then we take these three things, plug them in up here. R squared e to the rx minus 2r e to the rx plus e to the rx equals 0. Well, these all have an e to the rx in common. Let's factor it out. E to the rx, good luck naming value for x. It makes the left, or okay, let me back up a little bit. We can split it up into two separate equations equal to 0. Because we know two things multiplied equal 0, one of them must be 0. E to the rx, we don't get any solutions here because there's no value of x that makes it 0, unless you want to talk about like the limit as x goes to negative infinity, but that's not a number. So over here is the only place where we're going to get solutions for r. Sorry, there's no value for r or x that make that true. Over here, though, we do get r minus 1 squared is 0, so we do get r equals 1. It's multiplicity 2. This is probably not the best example to have shown this on because it's a repeated root, but I kind of wish I did one with not repeated roots now, because it makes the conclusion a little bit more direct. But the point is, like, this is where that heuristic polynomial comes from, and it's really with the goal of just solving for arcs. So we already have our guess where the solution is, and if anyone questions it, we can then later prove that it is a solution by plugging it back into the original. But like that's how that polynomial springs up organically. Is that a TIC? Oh, a TIC. I get it. Okay. Hey, Laylee Saley? Sure. In my Discord is the best place to put it. Or you can like upload it to the website and post the link as well. Figure out what ways for R make this happen. Basically, yeah, like differentiates. Oh, gosh. I'm glad I'm the only one who says derives here on Twitch. How does it work with this example? Y equals e to the rx plus e to the kx. Yeah. Oh, wait, what? Don't you get 4 solutions then? What do you mean with y equals e to the r plus e to the kx? Like, is that the homogeneous solution? Or are you saying there's like a differential equation that's equal to that? Actually, I shouldn't mention one more thing about this whole guessing what e equals to e to the rx thing, which is I think you can prove that the solution to the differential equation is unique. So if you found a solution, then you know that it must be unique. Don't exactly quote me on that. Obi probably knows better offhand, but once we've kind of made that good guess, we know there won't be anything else that also works. Like so, but in the differential equation. But yeah, awesome. I'll take a look at it just after this. Welcome in, by the way. So, oh, I see what you mean. Why can't we guess? Like, why couldn't we have guessed this and like did the same procedure here? I have a feeling you can manipulate this so it's not really 2 separate functions, and you're not fundamentally guessing something any different. If I factored out in e to the kx, what happens? We get that, I think. Wait. No. R minus k times x plus 1. Maybe it is something that's fundamentally different. I assume if you were to try something like this, you would just find that it doesn't work in the original. Maybe something that's not solvable for R and X, you might not have enough equations. Edison Nogales Antazana asks, how do you prove it's unique? I'd have to look at it, but I don't remember offhand, but I believe there's a way for these to show that it might be called Picard's theorem or something. Paul probably doesn't have a page on this. Someone somewhere did that work to prove that, or like to give a framework for how you can show a differential equation the solution is unique. I don't remember how though offhand. Okay, let me look at this and then we'll switch over to at least we'll take a little break to work on Laylee's question. The hell? Tay! No worries. Hi and bye to you too. Appreciate you saying that. AM squared. Right there. Okay, so if we back up a step and look at this last line, the only way this entire thing is equal to 0, like A, B, and C, they have the same coefficients. So if we had, it's the same exact thing as if we had y squared plus 2y minus 3 plus x squared plus 2x minus 3 all equal to 0. The only way this entire equation is equal to 0 is if y and x are the same thing that solve each of these things equal to 0 independently. Because like this entire chunk has to be 0, this entire chunk has to be 0. The coefficients are the same here. It's kind of like the important bit. 1, 2, minus 3, 1, 2, minus 3. I mean, I guess there's like you could always find. I mean, could you always find opposite values that cancel each other? Okay, I might be making. Might be a little bit of a leap here, but it's kind of like I think the point is that you have basically the same quadratics, just with different like variables. And I think at least the easiest way is to yeah, you get it out. I think there's like some subtleties I'm not addressing there, but it's something like that. you can like just look at one of them. Okay, and since it looks like we addressed that immediate question, let's switch over to Laylee's question here. It's on oblique asymptotes. Thank you for the follow, by the way. What is this here? Is this a mixed number, 2.5? Oh, geez. Yeah, it is. I see a 1.25 over there. So, Laylee, if you are still here, I'm still reading through this, but I guess, do you have a question about this work? Yeah, same here, Thunder. Oh, they complete the square. Okay. You don't like the notation either? Yeah, that's fair. How do you go from here to here? This is the difference of two squares. Well, is this a perfect square, though? That's what I don't get. I don't think it is. If I call shenanigans here, is Wolfram Alpha going to prove me wrong? Is that the problem? X plus 1 1/4 squared, which is 5/4 minus 25/16. That's really a perfect square? Oh, thank you, Judd. Okay, Wolfram Alpha doesn't find that simplification. It does? Yes. What? That's not the same thing, though, Judd. That's what we started with, more or less. But the square root goes away entirely. Like, I don't get how they make how the square. I guess if we square this, I guess that's the real test. If we square this, we should get this. Which there's no way. The more I look at it, I don't think this is. Okay. Anyway, let me look at what your question was. The last two questions were they reason what happens when x becomes big or small. Okay. I don't quite understand the math that's happening in this top line, but let's ignore that for the time being and actually address the question that you're asking. If x is a large positive number, we have y equals 3/4 minus x root 2. What? Oh, yeah, the foreignness it makes it a little bit hard to read, but okay, yeah, that's a good call, Jed, where for the sake of considering large values of x, this minus 25/16 is inconsequential. I'm on board with that. That makes a lot more sense. X is a large positive number. Yeah, Fembox. And I don't know, like, what they're doing with that plus or minus. I guess for this person, it looks like they're taking the minus. So they do 2. Yeah, they did 2 minus 1 1/4, but they should have included the root 2 here. Okay, they're doing a lot of stuff just by implying it here. So let me take their second to last step of the math. Okay. Hey, Phobos. Yeah. It's a little weird. There's some sketchy stuff that's happening in this image, I think. So I think they're talking about starting from this step for large positive x. We can say that this thing, we can ignore the 25 over 16, and we want to do it specifically so we get a nice simplification. Because we get squared square root, so those things will cancel. And they accurately put a plus or minus in front, but they seem to just kind of keep the minus sign for the sake of that first sentence, which is confusing, but okay. So after canceling squared and square root, we're taking just the positive version of this, so that minus sign carries over. It could have also flipped over to be plus, and they're just ignoring that for reasons that I don't know, but we can go with it. I think where they made the error here that Benbox pointed out is that they did not distribute that root 2 over here. So it should be root 2x minus root 2 times 1 1/4. I think they forgot that root 2 was there, and they did 2 minus 1/4 is 3/4. So it doesn't make this an error in the work here unless they just enjoy ignoring square roots. I hate this notation. So it should really be this, I think. They just forgot the root 2 and they simplified 2 minus 1/4 to be 3/4. I think it's the point of what they're trying to say though. And we could say the same thing for x being a large negative number. I don't know how to spell negative. I think they're making a second mistake here, which is they're saying that because, now that I think about it, I think they're saying because x is positive, we're only taking the positive thing from the canceling the squared and square root. That's not really true though. Because I think in the negative case, they do flip the sign. Plus x root 2. Yeah, they must flip the sign, and that's really not, that's not what you do here. You can do it, but I feel like there's an implicit misunderstanding here. So when I was saying before about like, this is technically plus or minus this thing, it's still true here. Just because x is negative doesn't mean we don't still need that plus or minus. Or at least the wording is a little bit imprecise, maybe. If they said like x plus 1 1/4 is less than 0 or something like that, then you can justify taking the negative version. But it has to be the entire thing inside there is you somehow know it's less than 0. Or you do know it's less than 0, but like, just saying, I mean, I guess, no, I guess it's okay. They're saying it's large negative x. I might be being too nitpicky. Yeah, okay. Maybe I'm picking on it a little bit too hard. I guess that's what they're saying. Because if it is a large negative x, you don't have to worry about that 1 1/4. Okay, fine. Sorry, I'm not doing a job of explaining this, but the thing I'm going back and forth on is that if you have the square root of something squared, you should technically say that it's plus or minus x. And so that's what I'll do down here. And what they're saying with the large negative x is just to take the minus case here, which I was reading too much into the wording, I think. I still agree with all the math that's happening, but that part of it is okay. So right here, I just took the negative, and then I said negative times a negative is positive. And then from here, we can start simplifying. So the root 2 does get distributed over there as well, or it's supposed to. And then there's not much more you can do to really simplify this. Like, you can group the constants, but you can't really do anything with them. So I don't know that I've actually answered your question necessarily, but what the written sentences are doing, just get back to your original question, you know, stop me from getting too lost in the math here, is we have this thing that we want to analyze, but it's a little bit messy. And if we only care about large positive and negative values of x anyway, we can kind of neglect that 25/16 to give us some easier algebra here, being able to cancel the squared and the square root. But to overcome this issue with having to deal with the plus or minus, they consider separately positive x and negative x. But I think there was a consistent error made in not distributing that root 2 into each of those terms, which I guess is the only, besides the formatting, is the only criticism that I can say of this thing. So I hope that makes a little bit sense. Please let me know if that helped or not. Sorry, it's always hard to explain things when I haven't quite figured out where they're going yet. That's kind of the challenge of doing math on the fly like this, but and so this kind of symmetry of the graph is what they're trying to deal with here. Like, it's another way of showing that plus or minus issue. Where like the large positive values of x are over on this right branch and the large negative are over on this branch, and you kind of need to arbitrarily say that to make the distinction. Better to write for large small x will be oh, right. So this question came from getting the oblique asymptotes. I did forget that bit. Two plus or minus x root 2. Probably. Like, 2 plus square root, oops, 2x. So it's a little bit offset. If we added on the other term that I wanted to, which is square root 2 times 5/4, it is a lot closer of a match. So it's the right slope, but the y-intercept isn't quite right unless you have that root 2 there. They might have claimed that this is an approximation to chop off the root 2. What is 3 1/4? 3 1/4 is 9/4? Is that it? No? No. 13/12. Oh, because that's at least closer. There's still a little gap there. Oh, 13/4. Duh. Yeah, they're just wrong. Because, like, this line just, it's the right slope, but 13/4 is just wrong for the intercept. Or at least, you know, that piece of the intercept. Like, just from graphing it, as Fenbox said. So yeah, if you take the thing that we arrived to for the positive part, you do get a exact match as well, or exact enough for the sake of getting the oblique asymptote. Yeah, so sorry that was so like messy lately, but I hope this helps, and thanks Fenbox and Jed for the help there. But yeah, it doesn't seem like there's an error in the work there, as best as I can tell. If you have any other questions, let me know, or any more questions on that. But whenever I see new people, I like to shout out that there's other math streamers than just me. So you don't have to do anything you don't want, but just in case you didn't know, there's a whole niche of math help folk out there, and everyone on that list there does like math help of some kind. So if you ever have another question and I'm not around, bring your head over. Oh, God. Yeah, I feel that. Was it like an answer key that was provided to you? That kind of sucks. Seems key. Oh yeah, it's no good. Okay. Unless it's a question from someone in chat, I guess I'm gonna switch to doing some studying to fill in the time. You can take it with a grain of salt, it seems. Unfortunately, it seems like it. Like, if you ever have a reason to potentially doubt it, like, I highly recommend you do what I did and just graph it in Desmos and see if it matches visually for questions like that. What's up with number 5? How big is an angstrom? 10 to the negative 10 meters. Oh. An A with a circle? Small. Oh. Okay. No one saw that. Maybe, okay, the composite material considered on a larger scale may be considered a homogeneous but anisotropic material with an electrical conductivity sigma subperpendicular for currents perpendicular to planes of layers. Homogeneous but anisotropic. I remember the book defined isotropic somewhere. I need to look back at that definition. We can consider two different conductivities for perpendicular and parallel to the plane. Given the conductivity silver is 7.2 times out of 10, find the ratio of sigma perpendicular over sigma parallel. And so I assume the thing that we're, like the task here is to figure out how this difference in thickness factors in. Doesn't the parallel conductivity depends what layer we're going through though? Oh, maybe they're saying, maybe it's over the entire thing though, so you're not just going in one lane, you're going in all lanes. So there's gonna be some kind of averaging that happens or something. Yeah. But we're gonna talk about like being isotropic. So I don't remember what that means. That's not good. That's really not good. What is this? Oh, good. We're down at 10.8. There we go. Oh, okay. It just means there's conductivity the same in all directions is what isotropic means. So there's not anything too revolutionary for the sake of the problem here. And the meaning of anisotropic. Now, how do I actually go about working out sigma? Is it length? The only thing that would be different, well, I don't know about the resistance. Well, we don't need to care about that. Wait. Are you going through it too? As a matter of fact, there is. I've been doing the official like reading groups on Saturdays. Yeah. We're on the same wavelength, 10 bucks. Actually, in the in my Discord, there's a channel for it as well. We're currently on chapter 4, and so yeah, it's kind of been a thing on Saturdays. We take about two hours to talk about whatever chapter we're on and work out some of the problems. So out of chapter 4, I chose out these problems just that interested me. And we either talk about the content or we go and like work through the problems as a group. And in the downtime, while there aren't questions from chat, I tend to open up the book and work through some problems that I didn't call out. Although, honestly, this list is so long, we're probably not going to get to all these, so I might do some off this list. Yeah, so you're welcome to join in the discussion, or hop in voice too if you want. That's also open on Saturdays, or just hang out and chat. But definitely feel free to like hop in. Oh, one more thing. If you want to get pings for when I make an announcement about the reading group, over in roles, you can go and hit the R to get pinged for reading group stuff. You don't have to if you don't want to get pinged all the time on Discord, but it's there. How do you interest in yourself going through unique killed all interests I had? So, yeah, I mean, when I took the class in university, I was not even slightly interested in this. Actually, yeah, I think physics, I see you're asking about like math and physics in general, but I think this seems a particularly good example where when I took the class in university, I did not think electricity magnetism was interesting at all. But in doing this kind of reading group for fun, I got to kind of choose, well, we did it as a group, but being able to choose the book yourself and kind of how you study it can make a big difference, because I chose this book because it uses a lot of multivariable calculus, which I think is really fun. And it apparently is going to get it into like relativity a little bit too, which I think is going to be interesting. So I'd say that if I have control over what and how I'm studying, that helps me have a lot more interest in it. If the experience that you had of going through uni killed your interest in it, that sucks to hear, and I'm sorry. I feel like you maybe just had a string of bad professors, which sucks. Or I wonder if it's maybe just like the way that I feel about math isn't the same way that you feel about math or whatever thing it is that you're studying. Because I very much just chose my major out of like just following whatever I was interested in. You think it's just, oh, like burning out? Yeah, that can happen too. If you're working too hard on something, no matter how much you like it, it's hard to stick with it. Even with that, I think the only thing you can do is to take a break if you think it's burnout. Which isn't always possible when you're a student trying to get a degree, but I definitely took like I did some math, but after I graduated, I definitely I didn't keep studying at the same pace for sure. I mean, if it's getting like really bad to the point where it's affecting you, like you might look into taking a gap semester or something, but university can be pretty brutal sometimes, so I recommend just kind of doing what's best for you, I guess, which probably isn't too helpful advice, but oh, nice. Let's see if Joseph is still here. So you're supposed to be easier at least? Okay, that's good. Um, yeah, I ideally take a break, and since it's not like you can't do that, depending on how you're feeling and how bad the stress is, either like put your head down and take a break after you graduate, or try to, and if you can't do that, then either try to take an easier semester or just take a gap semester or something. Because at the end of the day, you gotta take care of yourself. Otherwise, you'll, or it's like if you burn out, you're certainly not gonna, or if you completely burn out, then you're probably, it's gonna impact you way more than if you take like a small break now. Oh yeah, Femvox. I'm trying to work something out with like dividing these. Like I don't know, I feel like we can't assume that the resistance is the same. Maybe we can. But like I want to make some point about the the cross-sectional areas. I guess they don't necessarily cancel. Well, it depends. What is... That's weird. Okay, so for perpendicular versus parallel, L and A switch. Yeah, I guess maybe we want to do like an R1 and R2. Or like R silver and R tin? And like just let one be sigma L over A. And then we can work out I don't know what. It's like if we work out the resistance of silver, let's just say like perpendicular, I guess. We would have sigma. Do we even want to do it like, do we want to split it up? I guess we have to. Would they be considered like in series versus, oh, it could be a series versus parallel argument? Where if you're perpendicular, it's like you have a bunch of resistors in series. And if you're parallel, it's like a bunch of resistors in parallel. We still have to account for the different thicknesses as well. Okay. That's what you were thinking too? So our perpendicular resistance series, they just add directly, right? So let's say we have n layers. N layers each of silver / tin. N R sub s plus N R sub t. Now, for perpendicular, The silver is 7.2 times more conductive. Asuna! Thank you very much for the raid, Suna. How's your stream? I see you at least ended with some Overwatch. I hope that was fun. Just working a little physics problem here. Just thinking that in parallel, the current would have a choice of which layer to go through. Perpendicular, there's no such choice. Okay. So silver is more conductive, but less thick. So I think everything is linear here. For perpendicular, these act as lengths. So the tin is going to get a factor of 2, and the silver is going to get a factor of 7.2. This is a good song. I want to save it. One second. The playlist. There we go. So the resistance of silver is sigma silver, length of silver, over area of silver, plus n sigma tin, length tin, area tin. Silver is 7.2 times. I feel like this is maybe a weird thing to do. Now, the more I look at it, but oh well. And we're going to consider the areas equal. Now, I don't know how this math leads into the conclusion that I want to draw, which is that sigma... Oh, okay. Maybe I do see how... Well, I feel like this is... Why? I don't like 4.6 though. I like 3.6. I don't like 4.6. Oh, Suna, hey. I hope your stream was good. I'm reacted today that even after your main PC dying, it's still possible to raid from a second device. Oh, interesting. I saw that your PC died. Was it like during the stream? I'm doing well though. I hope that your stream was good, although if your PC died, then it dies all the time. Oh no, okay. Well, thank you for the raid. It's good overall? Okay. plus is 1/3 of L, LT is 2/3 of L. That could help make this more clear. It'd be nice to do something similar for the sigmas. Does the resistivity, I guess it would add directly. Really cool discussion about unique. Ooh, nice. Well, I guess I can keep that part the same. A third of L. Two-thirds of L. I want to do the same thing with the sigmas here. I feel like I know the answer. I'm trying to like arrive to it in a natural way, I guess. This is most of the original problem here. Number 5. There's a little bit on the little part there. Sean Kelly asks, can you show how to transform a binary multiplication into an SAT problem? I don't know what that means. Like asking an SAT problem about binary multiplication, or like I feel like that. Is binary multiplication just the multiplication of 2 binary numbers? Like, okay, yeah. I guess I'm still not really sure what that means, I guess. Or like what the goal is there. Hey, Yanis. Ooh, shouldn't it be 1/3 of just sigma plus 2/3 of just sigma? Well, no. Yes? Oh, wait, no, you're saying to factor everything else out. I see. Never mind, never mind. Sat on my ass all day. Yeah, I'm sorry, Shankar. I'm not sure exactly like what it even means to go from binary multiplication into an SAT problem. Oh, is there a video about it? Essentially factoring? I haven't seen whatever video that is, I guess. Um, so like, and like this is our overall resistivity. And then on this, are we saying that silver is 7.2 times of tin? I don't know what that math is actually. It's less than 3, or more than 3. But I don't feel like 9.2 over 3 is good enough for me, I guess. It still doesn't feel quite right. I feel like the book is just gonna do like they want perpendicular over parallel. I still want to like arrive to it more organically, but like actually, well, I guess we do need to. Maybe I'm either overthinking it or underthinking it, and I can't figure out which one. Yeah, that part I'm okay with, because I just get the factor doesn't feel quite right to me is my issue still. Lately, I'm kind of making some assumptions based off the formula for resistance that they give. In the case for perpendicular, I'm pretending that each layer is like a resistor in series, and resistors in series add directly rather than doing the weird reciprocal thing. And I'm just inventing this n thing. And the n, it really is not important though. ，Yeah, I. 9.2 over 3 just doesn't feel right, but how are we gonna so now if we just go with it and we look at the parallel case, this thickness it goes with the area now, but it's still gonna end up like we can still do a 1/3 and 2/3 thing. $500 angstrom by 500 angstrom cubed to do all the calculations. I think 600 would be a little more natural since it's 100 and 200. Even at that point, why not a 300? Yeah. How would that change it if we considered a single layer? I mean, I think that the single layer thing is we just take out the end from what I did. Does anything else really change? And the end I'm gonna remove anyway. And actually, it will make the parallel case a lot simpler. Because when they're in parallel, you can't do this, and it's not going to be as nice. Okay, I definitely like... Now I started thinking about what's going to happen for the parallel. This whole end thing is not going to be nearly as clean, and like it doesn't happen for the parallel case, so... I'll just pretend like it's a single thing. It's maybe still convoluted, but I still can't really think of a better way to show this, really. Those are supposed to be t's. This one's going to be kind of a pain to manipulate to get it like into a similar form as here. But let's see what we can do. So silver is 1/3 the area, tin is 2/3 the area. The length is all the same now. Why did that plus turn into, or that times turn into plus? Times. The A's cancel out entirely, don't they? Am I crazy? Yeah, I'm crazy. They don't cancel. Multiply by a squared over a squared. On top, they go away. The L's cancel, though. No, they don't. We just get a single L up top. Okay. I'm doing a lot of steps at once here. I'm sure I won't make a mistake on my mental math, though. I've never done that in my life. Wait. 9/2. It's a 3. It's a 3/2. Like that? I don't think I forgot my coefficients. Never in his life. Thank you, cognitive scientist. Not even once. I mean, and you know what, Yanis, I'm happy that I almost never have to do algebra. As in, like, the algebra that you like. Okay, so we can cancel a 3. Like, this part of it is definitely a little bit tedious, but thinking the problem out is super fun. And L over A can come out. 3 sigma S sigma T. The 2 can come down, get multiplied through. 2 sigma S plus the 3 and the 2 get canceled there, don't they? Sigma T. And this thing is going to be the overall sigma parallel. Which is kind of annoying, isn't it? I guess now we can do our substitution. Oh, not squared. Like that. So we do get just a single sigma t, which I think is good news. 3 times 7.2 over 2 times 7.2 plus 1, whatever that math is, I'm sure as hell I'm not doing it. The Wolfram Alpha can do this division for us. So sigma subperpendicular over sigma parallel, right? So these sigmas are rows. We're asking for sigma. Oh, wait, the sigmas are on the bottom, aren't they? Oh no. Oh my god. Ruh-roh. I even looked at it too, man. The sigma's on the bottom. Fuck. How does that change things? Ah. No, I mean, I can only blame myself. One time in linear algebra, we had to do something with Minkowski spacetime. Oh, I had someone ask me about that. We had inequalities in algebra. I cried. Oh no. I was thinking of it. They're asking about conductivity. I made it resistivity in my head, and I was like, oh, resistivity goes on top. But no, they're talking about conductivity. Yeah, the more I look at it, the more I like the idea. I don't have the same reservation as I did before about 9.2 over 3 being weird. Oh, okay. These bad boys go on the bottom. So does this one not change all that much? That'd be great. So isn't this is 1 over sigma perpendicular, is it not? Or is it? I think it's getting flipped twice. No, I mean, it's a factor on the outside. If it was in the denominator, I'm pretty sure it's 1 over. How do we want to deal with this then? Then we need to flip it. It looks basically just like the parallel case, which is kind of funny because of how we had that flipping happen. I don't know if it's good or bad, but I think this, unfortunately, I think this is just a teardown for the parallel case. This form might be easier to work with, though. I'm just seeing how it works for that form. All right. I almost did the same exact thing, dude. Okay. So silver is a third of the area of the unit. I think I'm on board with that. L is the same. 2/3 A sigma T over L. So we multiply L over L and just get the L up top. We can actually get a 3L on top. And we get A sigma S plus 2A. Excuse me. Okay, this is actually... okay, that's way less algebra. Okay, so sigma parallel is that thing flipped. And I'm going to sub 1/3 times 7.2 sigma T from that piece plus 2/3 sigma T. And Wolfram Alpha can take it from here. Oh my god. Yes. Chapter 4, problem 5. Okay, so we're doing perpendicular divided by parallel. Oops. So perpendicular was 3 times 7.2. Ugh. 3 times 7.2 over 1 plus 2 times 7.2. Parallel is, well, it is a fraction, but I didn't write it like that. 7.2 over 3 plus 2/3. And our factor is 0.457. Let's aim for a more fun number than that. Period 66 rational number. All right, I'm checking the answer key. If you don't want to know the answer, then avert your eyes. Wait 1 sec. Oh. Wee woo, wee woo, wee woo. Okay, okay, okay. Uh, 4573687. Yep. We agree. Okay. Now I'm looking at the answer. Oh, this seems promising just from the math that I'm seeing. Both right or both. Exactly. We're doubling down. Oh, okay. So they get rid of the sigmas right off the bat, which probably saves some effort. Our perpendicular glares are in series. So we got the idea. What's happening? Oh, okay. So they substituted on the left side of the equation too, which I think my way ends up being the same thing, but oh, wait, is that what I get? That seems like what I got for the parallel case, to be honest. Bro, thank you. $1.4? What? This is 1 over sigma t. Sigma... What? Wait, boom? Good? The final answer is right. Okay, I don't know why they get a different, like, intermediate thing here. Physics gods. we did one right for once without any hints. That's true. That's a rare occurrence with this textbook. You pulling out the ratio was especially clutch there. I guess in theory these three denominators should cancel though. But I don't know. Either way, I guess I shouldn't question a good thing here. So I'm getting in here as a witness. Yeah, he's not gonna believe us. Who would? Because it makes sense the conductivity is larger in the parallel direction due to the following reasoning. It's the case where the layer thicknesses are equal or one conductivity is much larger than the other. Ooh. Oh, we'll probably get different answers because... No, I don't know why. So the case where the layer thicknesses are equal. Is much larger than the other. So you take on by sigma 1 equals 1, sigma 2 equals 100. Sigma 2 is or sigma parallel. Perpendicular is approximately equal to 2, because the two regions essentially no resistance. What? Yeah, I mean, apparently, I guess that's my work was actually still okay. Yeah, I just need to flip whatever my final answer was. Because even though I used the wrong symbol, I did get the resistivity, I think. Oh well. Oh, Joseph. I don't know if you saw it, but Obi gave a recommendation for Fourier transforms. I scrolled up. I found it here. This is the book that Ensimplex Pachinko has. You can see that. I still don't get what's happening here. So perpendicular is when they're in series. So they should just, these are conductivities. The two region offers essentially no resistance. So why is total resistance half? You guys fun? All right, Yanis, thanks for hanging out. I'll see you around. As an exercise, you can give a general proof that sigma parallel is always greater than or equal to sigma perpendicular. We solved the question, they give us just another question right after. Okay, I don't really get this explanation, but I'm kind of done with it, so. More problems. Why are books so expensive? I don't know. I mean, at least for if you're willing to buy them used, I've used the book, the website. Is it called Abe Books? Yeah. I've gotten some like old textbooks off this site. And if you want help finding PDFs, I could maybe DM that to you. It's definitely legal. In case anyone was curious, I would never tell someone how to do something that's, you know, not legal. But yeah, there's definitely some ways to find PDFs. But if you want like a physical copy, that's where the few books that I have mostly came from. It's all like used, so I think it's owned by Amazon. Oh wait, is this the problem that Dr. Cook gave? I think it's similar. Need one more so I don't become too lazy. Oh wait, I didn't call out number 8? Let's see what 8 is saying. Because I thought I found all these infinity ones kind of interesting. Consider, actually, we might not even do, actually, wait, some of those triangles resistors. Oh yeah, we did that one on Saturday before last Saturday. Consider a two-dimensional infinite square lattice of 1 ohm resistors. Two-dimensional infinite square lattice of 1 ohm resistors. That is, every lattice point in the plane has 4 1 ohm resistors connected to it. Okay. What is the equivalent resistance between two adjacent nodes? This problem is a startling example of the power of symmetry and superposition. Huh. So there's going to be infinitely many paths to get there. Huh. What does it mean? What the equivalent resistance between two adjacent nodes? So it means they're directly connected to each other. I guess that's what adjacent means. Oh, freecodecamp.org? That's nice. Well, now, when I learn a coding language, I just start trying to write stuff and look up the syntax that I think I need, which is probably not a good way of learning a new language, but... Determine the voltage drop between two adjacent nodes. Say 1 amp goes in one node and comes out the other, then you are done. Oh, jeez. I'm yawning. Holy crap. All right. That just hit me out of nowhere. Sorry for making everyone else tired. It is a little hot today. It's making me lazy. I hope it's the last hot day of the the year here. Coffee time? Apparently. Hot here today too? Okay. Oh, you know, I probably didn't call out 8 because I probably was calling out too many of the infinite circuit problems. And I wanted to make sure I didn't only do those. Okay, so We have an infinite square of resistors, and we want to figure out let's put it over there. What do we want to figure out? The equivalent resistance between two adjacent nodes, which I'm interpreting to mean like, you know, we could consider that point A and that point B. Actually, let's go a little further out on the right. I mean, it's even better to choose the ones in the middle, right? Just to avoid making it too simple. And all resistors are 1 ohm. So you basically have the path directly between these, and then you have 3 other cases that are essentially resistors in parallel. And then all of those have 3 other resistors also in parallel. Like, you have to consider, I guess, every possible path. Two over pi ohms. I could believe that pi shows up here somehow. Hey, Viv. Yeah, it is. An infinite lattice of resistors. And the task is to find the basic resistance between 2 adjacent nodes. The hint says, determine the voltage drop between 2 adjacent nodes when a current, say 1 amp, goes in one node and comes out the other, then you are done. So maybe we need Kirchhoff. If you cut corners, every square is a circle, which is incidentally the shape of most pies. True, Viv. Don't know why I didn't think of that. Hmm. So You're studying between mathematical statistics and expository writing. Not a fan of either of those, personally. I probably get the writing class in there though personally. Well, actually, I might look at the professors that are teaching each of those classes, and if there's a good one, I would try to take that one. That's probably the real answer. So I feel like we're gonna have infinitely many equations and infinitely many unknowns, is where my mind is going with this. But how the hell do you deal with that? Maybe I'm not thinking with superposition enough. I should make it something simpler. Rank all the professors, whoever has the best rating, take their class. I mean, you don't have to do, like, you don't have to go to that level of it, but like, if you don't have to take either classes particularly urgently, I would just go for whichever one that's a, like, you know, just take a look at some Rate My Professor pages and see if one, like, stands out and try to take that one. It's more just to avoid a bad professor, I think. Do I need to study integration by parts and power series for Calculus 3? You might need an integration by parts sometimes, but not that frequently. Power series, I don't remember ever using in Calculus 3. There's in class used speed and everything last time? Okay. Yeah, I mean, I would just look for, I mean, I guess really, taking great professor is great, but it's more just like avoiding bad professors for me, I guess. Improper integral? I don't remember doing a lot of improper integrals in Calc 3. I don't think so. Are there any other in groups than... Yes, there are. Penn Center, who is another streamer, is doing one for abstract algebra. I think it's been unlocked so that everyone can see it. Does that work? Okay, yeah, that's the link for Penn's Discord right there. In this reading group channel, and like check the pins, and it should have, yeah, it has the textbook there. But yeah, that's for abstract algebra. He normally does his streams for it on Sunday, during the like West Coast American nights, like at like 7 Pacific or something like that. I should mention they're not reading groups, but they are interactive classes. N-Simplex Pachinko is doing a differential equations class on Mondays and Wednesdays. It's hosted in the same Discord here. And that one has like you can be there in chat, or if you want, you can also jump in voice and help work through some of the problems there. And then coming soon is a real analysis class from e to the 2y pi, aka Zach. E to the 2y pi, which will also have like a component of, or the class is basically whoever wants to gets in voice, and Zach just kind of lets you loose. And oh, there's an ow! Oh no! Okay. What a crappy time for an ad. It's supposed to be pre-rolls only. I hope you're not getting like extra ads. Like maybe if you refresh the page, then it would come up. Oh, Pen, no worries. We're about to do a second shout out because of a poorly timed ad. Yeah, I'm Momo. I hope you are too. So yeah, lately, if you scroll up in chat when I shout out Penn Center, and Penn Center's right there in chat too. Penn Center does an abstract algebra reading group on Sunday nights, and by Sunday night I mean like during the American like West Coast night. I think we're on like 7 Pacific or so normally. That's for abstract algebra. Just like check the pins in this reading group channel. And then there's that. But then there's also interactive classes. The other thing I was shouting out is that there's interactive classes that are being taught on Twitch. So Penn Center was also doing one for complex variables, but that one just wrapped up. And Simplex Pachinko is the next person I shouted out, is doing a differential equations class. Probably doing physics soon too. Oh, true, yeah. No, it should be hype, not psi. And so this Discord that I'm looking at is the Elements. It's linked up above. That Enigma posted there. So yeah, there's a differential equations class happening on Mondays and Wednesdays, hosted by Simplex Pachinko. They start at the same time that my stream starts. So in 2 hours and 20 minutes ago on Mondays and Wednesdays. And then the last thing I was going to shout out is, oh, and sorry, for this like class, there's an actual like, you can get on voice and solve the problems like with the class too. And then coming soon is a part 2 of analysis class from Zach on infinite series, or e to 2i pi. Who's the last person that lists the people who I shouted out? When is that starting? Did he announce dates? I don't remember. I feel like he did somewhere. September 10th. So that's in like 2 weeks. That's kind of crazy. Where's Zach's Discord? Yeah, I mean, hype. Thank you, Pen. Is it like that? Okay, cool. That's the Discord I'm looking at here. And so the way that Zach runs it is he's there and he guides you, but really like the people who want to hop in the voice chat and just solve through the problems, and Zach just kind of comes in and helps you get back on track, or gives like a little hint to like nudge you along. So it's not necessarily a reading group, it's an actual like class, which to me is even cooler. And on Monday nights, I think the next 2 Mondays and yesterday, he did like review sessions to help get people caught up. And I think that's all the exciting stuff that's happening with the math community currently that you might be interested in. He says like a cone today had a sore in his tail. Oh no. But was he like maybe it was like a plant that did that? Is there one for real analysis or calculus? Yeah, that last one, Zach, is real analysis. It'll be, this part is on infinite series, but he did one earlier in the year during the spring or winter. That was like just like your usual kind of like real analysis class, like mean value theorem, fundamental theorem of calculus, all those proofs. This one's coming up is going to be for infinite series, but for an upcoming thing for real analysis, or well, I mean, yeah, there's nothing like upcoming that'll be like on calculus exactly though, I guess. Hey, Lucas, I'm good. How about you? Nothing's from swimming in the ocean? Oh, dang. It's your typical calculus 2 topic? Okay. Yeah, I wasn't sure like how to describe her, because I don't know exactly what Zach is going to be covering either. Which I know he doesn't like that word, but I don't care. It's good to hear, Lucas. Got your books in for the upcoming school year. Nice, nice. Sounds like you must follow curriculum. Oh, I guess the other thing, Ian Stuckey. It's not really a group, but you can at least follow along with Ian Stuckey's progress on studying algebraic geometry. What Ian Stuckey's up to those is a little bit more like individual though. Something with matrices there. In the Discord? Or what are you talking about? Ivan Hatami? I'm probably pronouncing that terribly, but thank you for the follow. Welcome in. Your school book? Oh, okay. What book is it? Hey, Eva. I'm sorry. I think I'm supposed to pronounce it, but what's going on? So right now there isn't a question from, or like at least like a, where I mean it's kind of like chatting or right now because streams it's like a little bit of a slow part. Laylee Saley earlier was asking about reading groups in class. I was asking about reading groups that are being done on Twitch about math, and so I was answering that along with like some classes that are being taught on Twitch. And then, unless it's further on that, I was going to go back to studying some electricity and magnetism, which has been kind of a downtime thing that I've been doing. Yeah, 3 books for math. You're like Jesus. I did hear that Jesus was super into math. 3 new math books is like Christmas. Ugh. God, that reminds me. When I went to visit some relatives in Colorado last month, as like just like a little like nice thing to say thank you. They got me this Bible, and it's like a really nicely made Bible, but I'm not even slightly religious, so I'm not even sure like what to do with it. But like, let me go and grab it, because like nice books are still just like nice. Where did I put it? Here it is. But like, oh dude, it even like smells good too. Like it just like I assume this is leather, and like the pages have like that gold like thing on the outside. It's so like nicely made. Oh, it's even like, it's almost like Cliff Notes where it says the actual text and then it explains it in like plain English too. But like, yeah, I'm not sure. I don't know like what to do with it. Like, no. Sorry, you being the Jesus of math reminded me of that. What version is it? King James version, apparently. It's probably it's hard to read with the glare. ASMR book stream. Yeah. It's a book. That's true. I mean, it's a very long book, though. Ugh. Ugh. Just put it back into the back of the closet where it's been sitting. Loaves into fishes with no remainder. Oh. Jesus is trying to split up 10 loaves of bread among 9 people equally. I forget how that problem goes exactly. King James is a good version. That's one I grew up on. I don't remember which one I grew up on. I was raised Catholic. I don't remember the version, though. Don't know how the headphones feel so illegal to see. Oh, wait, they'll see me without glasses. Even I get weirded out when I see me without glasses. Used to read King James. I get sick of all of these and nows. New American Standard to English Standard. Oh, okay. Me without a beard? Oh god. I hope that's that I have no plans on getting rid of this thing. I feel like I look so much better with a beard. Especially because I feel like at some point I'm gonna have to like shave the like hair on my head once my hairline gets bad enough. So you're sure it's not felony? Oh, Maxi. Oh, bitch! Thank you so much, Maxi, for the raid. How's your stream? What were you working on? Max Wattage, hey! That one guy you knew before you, hey! I'm allegedly doing some studying right now on E&M. And before that, I was talking about some of the stuff that's happening in the math community with like what classes and reading groups are going on. But honestly, it's mostly just been chatting. Thanks that one guy you knew before. That's such a good video. How about lucid dreaming? Oh, cool. Allegedly, yeah. I've never actually lucid dreamed myself. I've heard that you can like train to do it if you like you can start by keeping a journal of your dreams and that helps you remember it. Some pinning of messages about manual breathing. Oh no, that's evil. Now I'm breathing manually. I was turning X's into T's. That's true. People were giving me problems involving like Y's function of X, and I kept on turning the X into T's because, you know, T is better. Making sure to avoid our peeling our skin off. Okay. You know, that's good. I personally prefer my skin not peeled too, so. Okay, I don't feel like thinking as hard as I've been thinking. And I get in the spirit of Maxi and all you being here, maybe we'll grab a little coding problem. Let's go to Project Euler. Then stream ended with a coin flip. I need to get VS Code going. Euler coin? Wait, is that the newest crypto? When was this problem made? You probably have to solve it. Oh wait, on 2020. Okay, yeah, this is definitely a crypto joke. Okay, well, let's do this one. Like, how many millions of dollars can I invest into Euler coin right now? Euler coin greater than Dogecoin? 2 pi dollars, yeah. An almost sequence is defined to be an Euler coin if it is strictly smaller than all previously found Euler coins. Huh. So you only get a new Euler coin once this n is big enough to make this entire number bigger than that one? Invest E dollars into Euler coin? Oh god. Find the sum of all Euler coins. So they must... I assume they stop after so long. These should be small enough that we can check if they're prime. And let's see if Wolfram can do it. Excuse me? I copied. I copied. What? I'm gonna right click and hit copy. What? But, oh, what? Maybe Wolfram just hates me. It's always possible. Okay, paste. Thank you. It's prime. The one on the right side of the mod. Ah. Invest the sum of all Euler coins into Euler coin. Okay, this one is factorable. Those are some interesting prime numbers right there. Oh, there is a 17 in there, true pen. So I think it's like a 5% problem. Or like it's like the easiest difficulty there is. So usually you can brute force these. I wonder if there's like a better like theoretical way that you can do it. Let me look. Okay, yeah, please do. Can we? Yes. The VODs should go up automatically on Twitch, and then I also dual stream to YouTube where they're up permanently because Twitch deletes the VODs after long enough. But all my math streams get dual streamed over to YouTube. Wait, this was 800? I forget. 700. Dang. So yeah, I technically have a minor in computer science, but my major was in applied math, so I should know how to code. I'm so incredibly rusty on it, and I don't mean that I know Rust like Maxi does. That I'm pretty terrible at coding. I was never that good at it in the first place, but Rust mentioned, yeah. Yeah, it's a sequence. So I don't really know how this modding thing is really gonna work. Like I don't know how to analyze this with a math lens. I do know how to just make a while loop and maybe track if we get like 10 in a row that aren't any smaller, then we can probably reasonably stop. Code up has arrived from the rate. That's true. Yeah. Our master race. Oh god. But yeah, I learned C++ and Java as part of my school in MATLAB, but I started to work on Python because it just feels like a good thing to have under your belt, at least some Python knowledge. Can I fit the problem on the screen at the same time? Let's see. It might be a little bit too chunky. I think we can make it fit. Oh, look at that. Just slides right in. Okay. I don't know what to call these numbers. Let's just call that one M, the other one P. I know it's important, but we can write the factorizations as well. You can't copy paste from over. Oh wait, maybe you can. Hey, let's go. Trying brute force, but it's not pretty. Oh, really? Could be a very large loop. Okay. It's probably a little bit overkill. Let's do like 50. While loops without new is less than 10. Coin is equal to m times n mod p. Uber, aka peanut butter. How's it going, dude? If coin is less than min Euler coin, then we found a new one. Min Euler coin equals coin. Is the first number large? Is it? No, they're the same number of digits, and the first one leads with a 1. You're still finding Euler coins as n approaches 1 billion? Oh god. Okay, well, that's not good. Some upper limits, what can be the next? Is there? I don't know like how to think about this. I just chose a problem because it was funny. I don't feel actually prepared to like do this one besides brute force. Saeed Paris, thank you for the follow. Sorry if I'm saying that wrong. 3N mod 57. P equals 57. Print F. That's how you format strings in Python, I think. Hell if I actually know. It stands for fart. True. Sean Kelly, thank you for the follow. We should probably, it'd be nice to track the total number of Euler coins. Num coins. I have so many like tracking variables here. We found num coins Euler coins. That's not right. Well, is it right? No, is it? There should be 3 Euler coins, right? So we can get 0, 1, 2, or 3. That's a potential. Oh, this needs to be bigger. Okay, I guess I see now. We should get. Are you kidding me? $506? Oh my god. Really? Why aren't I should be finding... Am I? Wait. What is the actual coin? It's the entire thing mod. Okay, yeah. What's order of operations on times versus percent? I have no clue. Just play it safe, I guess. It doesn't matter? Oh, maybe it doesn't. It might not be distributing it correctly, though, depending on how Python is doing it. It might be doing n mod p, and then multiplying that by just n, rather than m mod p. I'm pretty sure VS Code saves it for me. I never hit Control S, and I haven't lost any code, at least. I don't know if Python does the order of operation there, but the parentheses will take care of that anyway. Why would this not work? Then users hate this one simple trick. Yeah, I mean, I do this thing running in an Ubuntu like subsystem, but that's because I'm afraid I'm gonna like read in the wrong file or something like that, and I feel like it just gives me a bit of a insurance. Oh, the music stopped. What am I gonna play instead? I guess I'm doing that playlist. Who cares? You want to do 42 and mod 57? Coding demands. Oh, you don't have to ask me twice to play heavy metal. What do I want to listen to? I know. Where is it? There it is. Okay. First, I prefer my stream breaking every week. I use Arch. Oh no. M is supposed to be this number. P is this number. I think these are just examples to see if we get something that's reasonable. So, okay, but the thing I'm thinking about with 3, like, why don't we get... Oh, I guess I... No, I'm thinking about this wrong. They're multiples of 3. So, I mean, I can try it with the original values. Oh. Is that? No, isn't that the original number? 1504. No, that's not the original number. How many digits is that? That is a 16-digit number. That is a 16-digit number. They're getting smaller, though. Should I just see if this works? Let's just try it. YOLO it. Send it. It doesn't? Nope, it sure doesn't. Oh, and you're still finding it for like a... way bigger. Code optimization backseat. The less than 10,000 should use mincoin. Like scaling this in some way? Yeah, I mean, I don't really know how to have a good stopping condition, I guess. Besides, like, if we've gone enough loops without, I mean, we could just try it with the min coin. But min coin is me going, you know, so just try it. Do we expect to get a coin less than 10, I guess? Could we get unlucky and find it prematurely? Three, 6, 8. 8 digits is 40, so that's 42 million. So we need to go even harder. An interesting pattern in the Euler coins you're finding with brute force. You found 3 more after before you quit the brute force method. Do tell. What the heck is happening? They have a difference of 409,165 between coins after a while. I haven't. You don't really understand math unless you're like an inch away from it. That's why I'm leaning in this close. So like between like these, this hurts my eyes actually. I shouldn't be doing this. Is 409,165 one of the prime factors? Nope. I mean, oh, it does end in 5. I mean, I didn't notice that either, to be fair. I mean, that does mean we could split the mod up with the multiplication, though, right? Like, we could say it's the same thing as times n. Oh, that's like a special times character. Mod p in. Does this actually simplify the calculation? Like, all of these are constants, right? So do we only need to worry about whatchamacallit? Yeah, sure, Lunas. There you go. I mean, we don't have to do this. We don't have to do this factorization thing. We can just directly do the do that. Mod p times add times n mod p, and that entire thing is mod p again. Does that make it simpler? Because, I mean, that makes it calculate. The brute force might be a little bit better. Because instead of doing this, we can take m mod p times n mod p and mod the entire thing with p again. And I assume that's better? 10 with 100 zeros. This is 12 million only. Okay, so that doesn't really make it appreciably better. Well, maybe it does, but it's still like not good enough. Get me out of that. Can these have a ratio in common? It's kind of weird to me that there'd be like a constant difference, but like a ratio makes sense to me. Oh God. Oh, thank God, hard locked. I was worried sick. Hey, math channel, obligatory Riemann hypothesis mentioned for the day. Thank you. I was getting worried that no one would ask me to solve the Riemann hypothesis. Never leave me again, hard locked. Okay, these ratios, they don't seem like anything special. Never mind. I mean, we can look at the differences then. You mean mandatory solving the sine of z equals z? True. Oh. There is a pattern here. Oh, this song. Oh, my mic isn't like. I love the drums on this song, but my mic doesn't like pick up my tapping on the desk. Probably for the better, because it wasn't even slightly along with the song. Between coin 3 and coin 4. It's a good difference right there. So inconsistent, inconsistent, consistent twice, consistent 3 times, consistent twice, inconsistent unless it matches something way before or after. Consistent, consistent twice, consistent twice. I don't know what. I'm almost getting Collat's conjecture vibes where you get that like It's something like 1, 4, 3, 2 or something for the Collatz conjecture. It's kind of some weird like pattern like that for like getting them pairs or trios or singles or not. But that like unlike the Collatz conjecture, which I guess we don't know, but like this thing should decay. It like this pattern shouldn't go on forever. I don't know, man. I chose this one for the memes, and now I kind of regret it. I assumed it'd be easier because it was just a 5% difficulty problem. I find funny how easy your name can be read. Done doing... Oh, done doing math? I haven't gotten that one before. Usually people say Don does meth. Done doing math is a good one, though. Your brute force will finish soon, I hope. Okay. Debating making a new YouTube channel called Skibbity Math? Oh no. Oh my god. So that's the worst. No, yeah, I know. I mean, you know what, Peasant? I think you should. You know what I think going on, but I'm thank you for bringing out though, Uber. Yeah, it's always a little bit weird, but like, I love DayZ and I try to play, and I pretty much always play at least like once a week. But like, this is like my main shtick. I try to answer people's math questions, and when there aren't questions from chat, I just kind of like do some coding problems or do some kind of like studying like physics or algebra or something. So, I really don't know what to do with this problem. I feel like there should be a way to simplify this. Symmetrical properties, I'm not sure why the sequence should converge immediately. I just understand that it should. Yeah, I'm sure this has a, like, there should be some relevant math property here. I usually avoid modular arithmetic like the plague, though. So I don't really know it. Taking the nth every time the sequence should eventually converge. I'm not sure why/how. What do you even call this? Like, multiples of a number mod another number. This, sure, that's Google's problem to figure out what that means. Mod sequences? Okay. I don't know why I clicked on that one. It's clearly not relevant. Yeah, I mean, that'd be a great idea, Zach. Like, this is like Project Oiler. I clicked on it because I was like, haha, funny memes. It's like an actual like outline for like Euler coin, the newest crypto. Implement of a mod sequence, is it called? Let's invest in Euler coin. Yeah, I mean, we're calculating them all right now, so let's just like corner the market. I guess this would be like a limit thing. First I was crypto, then I was just math and programming instead. I mean, isn't that all crypto, kinda? Depending on your attitude, I guess. What's happening here? Oh, no, that's not... Never mind. Well, okay, mod sequence. Oh, like, for modding games? We need the glorious return of dance streams. It's been too long since I've heard true it in his voice. The order of A mod M. What is the order? Really? Next week? Is that a real thing, or are you playing with my heart? I don't see it on this Discord, at least. Next week. Oh, okay. Fingers crossed. Crossing your toes. Yeah, this is like it might be something that's good. Diophantine equation. Oh god. I feel like it might have to do something with like rewriting it like that. So it's because you only get a new coin if it's strictly smaller than all previously found coins. So it's not necessarily, it's like a running infimum more like than an actual infimum. As we go through the sequence. It is, yeah. Wait, you don't have that prime memorized? Come on, Zach. Um, there's infinite. You know, if you can't memorize infinite things, then you know, I don't know what you're doing. I don't know what thinking about this is even going to be helpful. I don't know what to do with it. Um, your 27th coin is still over 11 million. Phobos has 54 coins. Phobos is rich. There must be a way to figure out what the next coin should be, I feel like. Just Euler rich. This is like mining for crypto, except you don't even get money from it. It's true. Struck oil? Oh no. Oh. I'm never making a pun again. I think that one just wins. Oh my god. Where is our nonce? How do we add the new block to the chain? Ugh. I thought this would be brute forceable because it's supposed to be an easy problem. You teach foundations of Bitcoin / blockchain in your crypto course? Oh, as in like cryptography course, not like cryptocurrency course. That's cool. Do these differences have any relations to the factors? Like, what's the factorization of one of these things? $21.88. Does that show up here? No. The first few n? 13506 2527. Doesn't seem related. It can be written as the sum of 3 squares. That's exactly what I was curious about Wolfram. I think you can predictably know when it'll wrap around and be less than itself for a while. So we could skip over a bunch of pointless loops. Or like, you know, instead of incrementing n by 1 each time, we could, as soon as we find a new one, we could maybe bump n up by like a certain amount. That could speed it up. the big number divided by the middle number is like 2.9. So after 3 strides, you're at an Euler coin. The big number divided by the middle number. Middle number is little number. As in this n here? Like this 415 number divided by n? Or, oh, you mean this divided by this? So after 3 strides, okay. Huh. You can continually figure that out. What is thermodynamic? Like, I know that thermodynamics is like a physics class where you study temperature and something about it. I've never taken a class in it though, so I don't exactly know what thermodynamics all covers. It is dynamic, that is... There you go. I've heard it's a pretty difficult physics class. Oh, this song was just kind of weird. But yeah, I'm not sure like how to describe it. I've never taken a class in it, so I'm not sure. Maybe let's go back to simpler numbers and see if we can spot a pattern in those. 101 is prime, right? Probably. Don't ask me. Just do 4. Really? Oh, yeah, you're right. I got the rules mixed up here. Okay, so this is what I was thinking a lot earlier, which is if we're taking multiples of 4, at best, we can have 3, 2, 1, 0. Oh wait, it's not done yet. Oh, it's going to go through a bunch of loops, but you found them all, Zach? Really? How? Yeah, I should do a check for that, Jed. I was just gonna like go through that a bunch, but um, you thought you found them all? Oh no, okay. Min Euler coin. Phobos, your program is still going? Oh geez. Yeah, sure, Jed. Let's talk. Hello.
Hey, so one thought I had is you've got a number that the p number, right? So you're always going to when you're computing coins, it's always going to be a number that's less than p, correct?
Uh,
Because you're modding by p, so you can never have a number that you're comparing that's going to be more than p.
true.
Okay. So, and the other thing you can say is that as you examine the next number, it's always going to be whatever number you have plus m, right? So if you ever encounter a coin that you previously encountered, then you're stuck in a loop and you will find no more coins. Is that fair to say?
Uh, I think so,
So
yeah.
if I'm examining a coin and it's, a value that I got from multiplying m times some number and modding it by p, I'm going to get a value. If I compare that, if I look at that number, if it's less than if it's something I've encountered before, then I know what the next value I'm going to get is because I've already done that. So I'm basically stuck in a loop. So you know that there will be at most p different values you need to examine.
Uh, yeah.
So it is a finitely computable value. You just don't know if every value, every number under p is going to be hit. And so maybe I don't know if there's a way that you can determine if a number that's less than p is a multiple of, mn time, mod p. A multiple of m once you've modded by p. Can you determine that? Is there a mathematical formula for determining that there is a value n such that m times n mod p is equal to a specific value? Because then you have a fixed number of values you have to compute, and you can eliminate a large majority of them because once like the first couple that we hit are eliminating extremely large. Once we get to a value, we don't need to compare and look at any values higher than that because we know that it won't be a coin because we've probably already. Well, I don't know if we can do that. But anyways, it's just a thought
I mean,
or an observation, I guess, more than a. It's more of an observation that at most you're going to have p Euler coins. Actually,
uh,
that's not even true. At most you're going to have m Euler coins because the second one cannot be more than m. So
yeah, and like the order that we go through it is important too. It's like we might.
that's true. Is there a way to figure out the smallest value n such that p time or m times n mod p is equal to a specific number?
Um, times n mod p is specific number. I was trying to write out what the equation I guess would be.
Like m
It's
times n mod p equals 1. What's the lowest value of n given m and p? Is that possible to calculate?
probably we know what p is. We know what M is.
623132 is the
We have two
36th
unknowns.
coin. Yes, Zach.
Wait, no. It'd be like P is equal to M times N. And then like if we want 1, well, okay, yeah, we know what P and M are. We could solve this for N.
Can you?
It'd be N is equal to P minus 1 over M. If you wanted your remainder to be 1.
But you're not counting
Right.
the fact that it's M times N mod P. So it could be.
But this is just like
M to
the definition of division.
M times.
It's like if we wanted.
Yeah, but you're looking for an integer value N. And if you don't find one for P minus 1 over M, then you need to basically multiply the numerator by P, or add P to the numerator, or something like that, right?
Something like that, yeah.
Because you don't. There's a value on like M times N plus 1 is equal to some multiplier of P. So you actually have two unknowns there. Yeah, I stopped my loop when I got down to 7.2 million. So I was in the 7-digit range at coin 37.
Phobos has an idea.
Anyways, it's just some thinking. Maybe it would spur some idea of maybe a way to not brute force this, but to come up to identify a pattern or a alternate approach. I mean, it comes to some point where you're looking at M. You know that sometimes you can add 3 M's before P is, because once you get to a value that's once you get some coin value, you need it to wrap around P before you even need to check the next value. So you could actually add multiple M's to get it to overflow P, so the mod comes out to be smaller. And it's just a matter of figuring out, okay, how many times do I have to overflow it before I'm going to get a value lower that, you know, maybe it's maybe looking at the cycle of the remainders, or of the how many times it goes into it. I don't know. Oh, Zach's got something.
Oh? But wait, there's more.
He might have to join us.
Okay, if you want to hop in voice too, feel free. Or if you just want to put in chat or a screenshot or something, that's cool too. But
I tried some things, like instead of calculating N times, M times N and then modding it, I changed it to like an addition with a optional subtraction. So then it wouldn't have to, I don't know if that's easier on the computer to do plus and minus than it is to do multiply divide. But to see if maybe that would speed it up with any significance, and it didn't. And then once we got to that part where we had the repeated difference, I tried to take that down to 0, and that answer doesn't validate either. And it was running for a while to see if there's maybe something smaller. Then, because I got the 54th coin as being like a 6-digit number when I did it that way, and then the 55th would be a negative number, but that doesn't mean there's nothing in between them. Yeah, Zach, we'd seen that, the 409165, I think it was.
At least there's some like singletons, and there's some pairs, and there's some trios, but there's definitely a pattern happening.
Well, once you get down to, like, how far did you get your coin differences down? Because eventually the differences come to 409165, and it repeats that difference for several iterations.
Oh, really?
That take, yeah, I mean, if you just let it run, you'll see, while you're chatting or whatever, and just see kind of what you.
As I said, I would be
see those differences, and yeah, you're going to see it's like, okay, the difference between this coin and the last coin was 409165, and then the next coin is 409165 less than that, and it repeats that pattern. I'm not sure if there's something specific about it. I mean, 409165 has, you know, different factors than M or P, but I'm not sure if that's.
Yeah, I looked at one of the differences and it didn't have any factors in common.
Anyways, that's all I wanted to just, you know, maybe
Okay.
throw that out there, see if it sparked something that, hey, okay, we know we're going to have some value that's going to be, you know, the number of coins that there can be has to be less than M. Because if it were more than M, then one of those values had to be bigger than M, which is not allowed. Because the first coin is M.
Yeah.
And since
It's
it's
still a
smaller
pretty
than
huge
P,
number, though.
I mean, the mod itself says that there could be P maximum, and then the M further restricts it because M is less than P for the first value. And then when you cut out the large number of chunks, you know, that you that you get out of you know, the first couple of hits you get, you know, you're dropping it from whatever that first number is to whatever the second number is. It's a huge range of numbers now that you've eliminated as possible coins.
Yeah.
Yeah, I mean, you went from, I mean, you lost what, 4 orders of magnitude there, or 3 orders of magnitude, and then the next one you know, cuts it in quarter, and the next one cuts it in quarter again. So
I want to try plugging these n values into OEIS and see if something pops up.
and see if it comes up with a.
I feel like there should be something here. Oh, that's an approximate match. Doesn't seem like it. No exact match.
What about the actual coin values themselves? Like
Could
the
try
first
that.
3 or 4 coins that you find, and see if there's a.
Let's see if OES is going to hate huge numbers like this.
Well, I mean, they've got mainframes that can calculate patterns and stuff, so somebody may have run it and said, "Oh, here's a pattern."
Maybe, yeah.
And they've got. You do 3 coins and see what it comes up with. Oh, first 4.
Nope.
All right, that's all I wanted to bring up. Take
Okay.
with that what you will, and see if.
Thanks for the thought.
Yeah. Sometimes it works out. Sometimes it doesn't. But,
I mean, it might
we'll
still spark something, but we'll see.
yeah, I'm going to keep working on that one. I've got a few of the project. I've been kind of working my way through some of the ones I solved just to have that program in my archive. But I've also been trying to pick up a few new ones. So you're doing 700. It's like, okay, let me jump to 700 and see if I can find anything. It's like I'm still like, you know, I think the highest one I've done is like 34 right now.
Oh, you're going through them like in numerical order?
Yeah, because it would stand to reason some of the first ones are some of the easier ones.
Yeah, that's fair.
I know I've done some. I don't know what my progress is. I've gotten my highest one I've actually solved number 69.
Aha.
Yeah, it's Euler's totient function.
Oh, I might have done. I feel like I looked at it at least.
Yeah. So I did that one, and 67 are my 2 highest ones of the 904 that are in there. One of the ones I've done has a difficulty rating of 15%. Which one was that?
Those are kind of a lot. Like this one is an easy one, supposedly.
62, but I think that's the. I don't remember how I did that one, but I got the answer for 62. But that's a more complex problem. Anyways, I gotta run.
Okay. See you.
But catch a chat.
Yep. Okay. Oh, I get why they're bringing up Euler's birthday. April 15, 1707. April 15, 1707. Okay. What is this number then? Maybe just a arbitrary, or it's just a big prime. Ugh. There's gotta be some simple way of doing this. No, never mind. All right, I might have to throw in the towel on this one, for now at least. Kind of just out of ideas. Can't believe that's a 5% problem. Hmm. I gotta be honest, after thinking really hard about that problem, I kind of don't feel like thinking anymore. Ugh. I really don't know what to do with this. Besides just keep on looking at simple examples and hope I eventually spot a pattern. Okay, see, with 24 and 101, we get 5 4 times in a row, and then 1 4 times in a row. One, 2, 3, 4, 9, 14, 19. What if we took 50? Maybe a bad choice. Huh. This one we get it for every single number. I think it's probably just because it's not a good choice though. 49? Huh. This one goes by threes. It should always terminate at their least common multiple. Could we work this backwards and look for a pattern in the reverse direction? Like, I want to get an irregular pattern. Like, why? This is just always 3. We were definitely not getting... I deleted the list of primes that I found for one of those composition problems. Did I? Which one? Yeah. Let's get a 7741 as prime. Really? Weird. I really don't know what to think about this. Hmm. One, 3, 5, 7. Wait. 1, 3, 5, 7. 1, 3, 5, 7. 2152 doesn't appear up here. There is a symmetry. 20, 31, 73. No, only the first few. I don't get how this is an easy problem, man. Some of these difficulty ratings are all out of whack. That's the word. Can't speak. You know, this can actually just be our ending condition. So that should always be our stopping point. Too tired to program your solution? I feel similar. I mean, I don't really have a solution, I guess, but it's just like a hot day, and I'm about to like just call it because brute force will buzz first. Like, okay, I was to hear Zach's pattern. I guess it's unfortunate timing on him having to like go right then, but yeah, I guess be one of I was thinking that I could do this by brute force and then see the smart people on Project Euler saying like the right way to do it. But that plan did not work out how I hoped. All right, honestly, I think I'm just gonna call it for the day here because I don't know, I'm tired, I guess. I'm definitely interested to hear about that problem, but I'm stuck on it and I don't really feel like starting another one. It's like there's no one else is gonna have a question today anyway, so like a regular like math question, so let's cut the YouTube stream here. So if you're here on YouTube, I appreciate you. Back on YouTube on Thursday.